Hello. So we'll be doing some problems related to limits. Students have sent some problems, so I'll try to show you. So the first problem is limit theta tends to 0, sine q theta 1 theta square 1 plus cos theta. Okay. So now we'll use one limit law or properties of limits and use that. So limit x tends to a fx multiplied to gx can be solved by limit properties or limit law fx into limit x tends to a gx. So we can have this. So we'll use here and I'll put this as sine square theta over this and sine and limit theta tends to 0 and sine theta over 1 plus cos theta. Now we'll use another limit law where limit x tends to a. I'm just doing this as so. This will be f of x n can be written as limit x tends to a f of x n. So we'll use the same here. Limit theta tends to 0 sine theta over theta square. This can be written like this. This is limit theta tends to 0 sine theta 1 plus cos theta. So this would be using this limit law. This can be put as theta tends to 0 sine theta like this, and this will carry on. Okay. Now there is another limit formula. When limit theta tends to 0, sine theta over theta is equal to 1. We can deal with this proof separately. So this is one of the law we can use. So 1 square will put. Now sine of 0 is 1 plus cos 0. So sine of 0 is 0. Cos 0 is 1. So this will give us 1 into 0 by 2. And this will give us 0. So the limit of this function fx is 0. Now the second question here is uses absolute values. So the function here is given is x minus 4 over x minus 4, where x is not equal to 4, and we have to find the limit at x equal to 4. Basically, how the function is behaving around 4. So let's first find out left-hand limit of this. Left-hand limit means if the function is going on like this, it's not like this and this, but just the values before 4. That is left-hand limit. And the values after 4, very close to 4, but on the right side or greater than 4 is right-hand limit. Left-hand limit is values less than 4 to very close to 4. So x tends to 4 minus. 4 minus means it the left-hand limit. It's close to 4 but less than 4. So this is limit. Now x is, so x plus h is 4 here. Okay. So x is for left hand. So x is equal to 4 minus h, because h is a very small distance and x is somewhere here less than 4. So instead of x, we can put 4 minus h. So this will be, we can put here as h tends to 0. So limit h tends to 0, 4 minus h minus 4. So absolute value of negative h is just h or negative h. Okay. So h and h will cancel. So this will give limit h tends to 0, negative 1, and it would be negative 1. So we got the left hand limit as negative 1. Now for the right hand limit, x tends to 4 plus f of x. So here, if the graph is like this, 4, here the graph is not like this for this particular question, but I'm just showing you. So x is somewhere here, 4 positive means after 4, at a small distance h. So x is equal to 4 plus h, and this x is here. So 4 plus h in this case. So it is little x is above 4, little greater than 4, and it is h greater than 4, means that h is a very small positive value. So we can put this as limit h tends to 0, f of 4 plus h, and this is equal to limit h tends to 0, 4 plus h minus 4 is equal to 4 plus h minus 4. So this will be limit h tends to 0, 1. So absolute value of h is h where h is 1, and limit h tends to 0. So we see that left hand limit was -1 and right hand limit is +1, and left hand limit is not equal to right hand limit. So limit at 4 doesn't exist. Okay. Now we'll do the next question. Next question is limit x tends to 0 plus log of x, and so in this case again we'll use the limit law where limit x tends to a, f of x and g of x is equal to limit x tends to a, f of x and limit x tends to a, g of x. Okay. So we can use this limit x tends to 0 plus log of x. So we see the graph of the log as we see. It's like this. So we see that as it is more towards 0. This is the graph of the log function. As it is more near to 0, the value goes to -infinity. So we can say the first function is -infinity, and for the next for this one, as x is near 0 and it is 0 plus, so it will be +infinity. 1 over 0 is infinity and this is positive, so it will be +infinity. So negative infinity multiplied by positive will give us negative infinity. So the limit at 0 extends to 0 plus of this function is negative infinity. What will be the limit of this function when x tends to 0 minus? For this function, we see that log value doesn't exist for negative x. So we see here that log value doesn't exist for the x negative axis. So this limit will not exist. Now we'll do the next problem. So the next problem deals with absolute value. So suppose this is t tends to 5 and 15, absolute value t minus 5. Okay. So we know for the absolute value a is it is equal to a is greater than equal to 0 and negative a when a is less than 0. So this function t minus 5, this function is 0 at t is equal to 5. So t minus 5 is equal to t minus 5 when t is greater than equal to 5 and it is minus t minus 5 when t is less than 5. Okay. So limit t tends to 5 minus, so it means this is the function we are, this is any function. The function is not like this, but just I'm considering. So we are seeing, we are looking at the left hand side, the values less than 5 or the left hand side of 5. So this would become 15 minus t minus 5, which would become t 15, 20 minus t. And when we put it 5, this becomes 15. So the left hand limit we got is 15. Then limit t tends to 5 plus, this will be equal to 15 plus t minus 5, which is equal to 15 plus t minus 5, because when t is greater than or equal to 5, it is t minus 5. Now if we put 5 here, we will get this will be limit t tends to 5 plus, which will be 10 plus t is equal to limit t tends to 5 plus, which is this will be equal to 15. So we see that right hand limit is also 15. So limit t tends to 5 plus 15 plus t minus 5 and is equal to t minus 5. This is absolute value. So left hand limit is equal to right hand limit. So the limit t tends to 5, 15, absolute value t minus 5 is equal to 15 and it exists. So the next question we are going to do is we have to find the value of k. This is x. X tends to theta. 6x squared plus 100 minus 4x plus kx squared is equal to 1. So we have to find the value of k for which the limit is equal to half. So find value of k for which limit is equal to half. So in this what we can do is divide numerator and denominator by the highest power of x. So x tends to infinity. 1 by x square, 6x square okay. So this gives us limit 6 over 100 x square minus 4 over x plus k. We know that 1 over infinity is 0, so 100 over infinity would be so this would be equal to 0 plus 0 is equal to k. And this is given here is half. So it means 6 by k is equal to half. So k is equal to 12. So if we put k is equal to 12, this limit of this function will come to as half. Now the next question we'll do that deals with the absolute values again. So find limit x tends to 4, 5x minus 20 is equal to 8 minus 4x. So we'll take the common out. So this is x minus 4 and this is absolute value of 4 minus x. Okay. And in this we know that 4 minus x is negative when x tends to 4 plus. Okay, when x is greater than 4, this would be negative. Okay, so limit x tends to 4 plus, so this would be 5 2 and this would be negative 4 plus x. Okay. And this would be x minus 4. So this would give us limit x tends to 4 plus x minus 4 minus 2 x x minus 4. So this would give us 5 by 2. So because 4 minus x would be negative, as x tends to 4 plus, this x would be greater than 4 and this would be negative. So we will write as minus 4 plus x and this is x minus 4. So they will cancel. And the limit would be 5 by 2. Now if we, this would be right hand limit. Now finding left hand limit 4 minus, in this case, this would be positive. Okay. When x tends to 4 minus, so 4 minus x is positive. When x is less than 4, okay, because x is less than 4 in this case, so it will be less, so it will be positive. So this would be x minus 4 and this would be, we can write like this. Okay. So this would be x tends to 4 minus 1 5 by 2 x minus 4 over x minus 4. This would cancel and this would give 5 minus 4. So we see that left hand limit here is not equal to right hand limit, and that's why the limit will not exist. Okay. Now there is one more problem here. This includes square root and rational functions, limit of the rational functions. So when we have to solve these problems, we can just uh, we can multiply with its we can multiply with square root x square plus 3 square root plus 2 from numerator and denominator and try to simplify it. So this would be x plus x square plus 3 plus 2. So this is a minus b and a plus b form. This is a minus b, a plus b form. So this will be a square minus b square. So we can write like x square plus 3 minus 4 x plus 1 and x square plus 3 plus 2. This would be x square plus 3 plus 2. Now again using the same formula a minus b a plus b is a square minus b square. So x square minus 1 would be, this is x raised to, this would be x plus 1 x minus 1 x plus 1. Now if we put minus 1, this would be minus 1 minus 1. This would be 1 plus 3 square root plus 2, which will give minus 2 over 4, and this would be minus half. Thanks for joining. We'll again do more problems in the next class. Thank you.